Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study Math, Science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Maths Chapter 22 Heights and Distances. We'll be solving questions from Exercise 22C. Hope you all are ready with your pen and papers. Let's begin. Here we have the first problem, question 1 of exercise 22C. To find AD. In this question, we need to find AD. Here we have AD. Okay. What is given? Here we have 5 centimeter. BC is 5 centimeter. CD is 20 centimeter. Which means we'll be having ED is also equal to 5 centimeter. And CD, BE, they will be equal. That is 20 centimeter. Here we have a perpendicular, which means ABE is a right triangle. Yes. How to find AD? AD, we have AD is equal to AE plus ED. AE plus ED. ED we already know it is 5 centimeter. We just need to find AE. How to find AE now? When you consider the right triangle ABE, consider triangle ABE. In right triangle ABE, we have tan 32 degree is equal to opposite side by adjacent side. Opposite to 32 degree, we have AE. AE divided by opposite to angle 32 degree AE, adjacent side is BE. AE by BE. Then we can write AE is equal to BE into tan 32 degrees. Okay, just crossing. BE into tan 32 degrees. What is BE? BE is equal to 20 centimeters. So, 20 into tan 32 degree. We know the values of tan 30 degree, tan 0, tan 45 degree, tan 60 degree and tan 90 degree. How to find 32 degrees? For that we will be using the natural tangents. Here in page number 454 of Selina publication textbook, to find 32 degrees, take the natural tangents. 32 degree, 0 minutes, you can check. You will be getting 0.6249. So that is the value. 20 into 0.6249. On multiplying this, you will be getting the final answer, and that is equal to 12.5. Okay, 12.5 centimeter is AE. Once you get AE, we can easily find what AD is, because AD is equal to AE plus ED. AD is equal to AE plus ED, that is AE 12.5 plus ED is equal to 5 centimeter, which is 17.5 centimeter is your final answer. AD is equal to 17.5 centimeter. Okay. So here we have the second figure. We have a triangle ABD, which is a right triangle. Within triangle ABD, we have ACD, another right triangle. Now given that AB is equal to 30 meter. AB is the hypotenuse of triangle ABD. Okay. Given AC is equal to BC. If AC is equal to BC, we know that angles opposite to equal sides are equal. Now consider triangle ABC. Consider triangle ABC. Okay. In triangle ABC, we have AC is equal to BC. Therefore, opposite to AC, we have angle ABC. Angle ABC is equal to angle BC. Opposite to BC, we have BAC. BAC. Also, we know that angle ABC plus angle BAC is equal to 48 degree. What is the reason? When you consider this triangle ABC, okay, these two are interior angles and this is an exterior angle. So we know that the sum of interior angles is equal to the exterior opposite angle. Yes, due to this reason you will be getting ABC plus BAC is equal to 48 degrees. Also we have ABC and BAC are equal. Then we can write 2 times angle ABC is equal to 48 degrees. Why? Because BAC is equal to ABC. Okay. Then angle ABC will be 48 degree divided by 2 and that is 24 degrees. We got this angle 24 degree. Okay. Now take the big triangle ABD. We need to find AD. Okay. We have tan theta is equal to opposite by adjacent. If you use tan theta, is there anything that we can do with it? No, right? We are given the hypotenuse. Okay. And AD is the opposite side when you consider this angle ABD. Okay. Opposite side we need to find and hypotenuse is given. Opposite and hypotenuse. Then sine, cos or tan? Yes, we will be using sine. Sine of 24 degrees will be equal to, sine 24 degree will be equal to opposite side AD divided by hypotenuse AB. Okay. We need to find AD, therefore AD will be equal to AB into sine 24 degree. When you check the natural signs, you will be getting sine 24 degree equal to 0.4067. Okay. What is AB? AB is 30. 30 into 0.4067 and the value will be 12.20 meters. Okay. AD will be equal to 12.20 meters. So when you multiply 30 and 0.4067, you will be getting 12.20 meters. Understood? Now the second problem, question 4 of exercise 22C. Here we have a figure, a triangle AMO and BNO. We have to find AB. AB will be equal to AO plus BO. Yes. AB is equal to AO plus BO. We have to separately find what AO is and what BO is. Okay. To find AO, consider triangle AMO. Consider triangle AMO. In this triangle AMO, angle is given 30 degree. Okay. With respect to this angle, we have hypotenuse of triangle MO given. We need to find AO. AO is the adjacent side. When you consider this angle 30 degree, AO is the adjacent side. Adjacent side and hypotenuse. Adjacent ratio of adjacent side and hypotenuse, it is cos. So cos theta will be considering, that is cos 30 degree. Cos 30 degree will be equal to adjacent side AO divided by hypotenuse MO. Okay. We need to find AO. AO is equal to MO into cos 30 degree. Okay. MO into cos 30 degree. Now what is the value of cos 30 degree? Cos 30 degree is equal to root 3 divided by 2. Therefore, AO is equal to, value of MO is 6. 6 into root 3 divided by 2, that is equal to, cancelling, we get 3 here, 3 root 3. We know the value of root 3, which is 1.732. On multiplying, you will be getting approximately 5.20 meters. Okay, this 5.20 meters is AO. AO part we got, that is 5.20 meters. Now we have to find BO. Okay, here we have angle 47 degree. 47 degree, opposite side is BO. And in this triangle BNO, NO is the hypotenuse. Okay, consider triangle BNO. Okay, here we need to find the opposite side. Hypotenuse is given. Ratio of opposite and hypotenuse is sine. So, sine 47 degree is equal to BO divided by NO. We need BO. BO will be equal to NO into sine 47 degrees. Okay, how to find sine 47 degrees? When you check the natural sines from the sine table, you will be getting the value of sine 47 degrees. Sine 47 degree, 0 minutes. The value is 0.73. Okay. NO is given, which is 5 meters into 5. That is equal to BO. To get BO, we multiply 5 and 0.73. You will be getting 3.65 meters. Okay. 3.65 meters is the value of BO. BO is equal to 3.65 meters. Then what is AB? We have AB is equal to AO plus BO. AO we have already determined, which is 5.20 meters. 5.20 plus BO. BO is 3.65 meters. 3.65. Okay. On adding, you will be getting final answer 8.85 meters. This is the value of AB. Okay. AB is equal to 8.85 meters. Okay. Problem 3. Question 5 of exercise 22C. The radius of a circle is given as 15 centimeter and chord AB subtends an angle 131 degree at the center C of the circle. Using trigonometry, calculate the length of AB, then the distance of AB from the center C. Okay. Here we have a circle. AB is a chord. We have a center C. The angle subtended by the chord at center C is given 131 degree. Okay. First we have to find the length of AB. This length we have to find. Then we have to find the distance of AB from the center C. Distance of AB from the center C is a perpendicular distance. Okay. This is the distance. Let's take a point P. Now, when you draw a perpendicular from the center C to any chord on the circle, what happens? The chord will be equally bisected. Okay. That is, AP will be equal to BP. This is a perpendicular bisector, which means the angle will be equal. The angle ACP and BCP will be equal. When you drop a perpendicular bisector to any chord, there is an angle bisection happening. Okay. ACP and BCP will be equal, which means ACP will be half of 131 degree and BCP will also be half of 131 degree. We have angle ACP equal to angle BCP. They are equal. And therefore, angle ACP equal to angle BCP equal to half of 131 degrees. Okay. ACP equal to BCP is equal to 65.5 degrees. 65.5 degrees. Now, here we got the angle 65.5 degrees. This angle is 65.5 degrees. Okay. We have to find the length AB. AB is equal to 2 times AP. We can write AB is equal to 2 times AP. Because CP is a perpendicular bisector drawn from the center C. Okay. AB is equal to 2 times AP. If we are able to find AP, we can find AB. AP is a part of triangle ACP. Yes. Consider triangle ACP. Okay. It is given that the circle's radius is 15 centimeter, which means AC is 15 centimeter and BC is also equal to 15 centimeter. AC is the radius. What is radius? From the center to any point on the circle, when you draw a line, it is the radius. So this AC is 15 centimeter. AC is the hypotenuse of triangle ACP. This is a perpendicular bisector, which means here we'll be having right angle. Okay, hypotenuse we have, and we have to find AP. AP will be the adjacent side. Okay. So when you consider this triangle, taking with respect to this angle, it is the adjacent, and with respect to this angle, that is 65.5 degree, here we have adjacent and this is opposite. Okay, so adjacent, opposite. We need opposite. To find opposite, hypotenuse is also given. Opposite and hypotenuse will be taking the sine value. Okay, sine of 65.5 degree is equal to opposite AP divided by AC. Okay, sine 65.5. 65.5 degree is 65 degree 30 minutes. When you check the table, you will be getting 0.91. 0.91 is equal to AP divided by AC. AC is 15. And therefore, AP will be 15 into 0.91. The value will be equal to 13.65 centimeter. Okay, 13.65 centimeter is AP. So we got AP. Now we have to find AB. AB is equal to 2 times AP, that is 2 into 13.65 centimeter, which is equal to, we get 27.30 centimeter. AB, the length of chord AB is equal to 27.30 centimeter. Next, what we have to find? We have to find the distance of AB from the center C. Distance of AB from the center C is this perpendicular distance or the shortest distance. We have to find CP. How to find CP? Again, consider the triangle ACT. Okay, with respect to this angle, we have hypotenuse and CP will be the adjacent side. Okay, therefore, we'll be using adjacent by hypotenuse. Cos of 65.5 degree is equal to CP divided by AC. And CP will be equal to AC, 15 into cos of 65.5 degree. 65 degree, 30 minutes. When you check the value, you will be getting CP equal to 15 into 0.415 is the value of cos 65.5 degree or cos 65 degree 30 minutes. When you multiply, you will be getting the final answer 6.22 meters. Centimeters. 6.22 centimeters is your final answer. CP, that is the distance will be equal to 6.22 centimeters. Clear? Here we have the next problem. Problem 4, question 7 of exercise 22C. A vertical tower stands on horizontal plane and is surmounted by a vertical flagstaff of height h meters. At a point on the plane, the angle of elevation of the bottom of the flagstaff is alpha and that of the top of flagstaff is beta. Okay. Prove that the height of the tower is h tan alpha divided by tan beta minus tan alpha. This is a proof type of question. So, let us make a rough figure. Here, this is our horizontal plane. Okay. Here we have a tower AB. Okay. Then the flagstaff. Here let us consider a point D. From the horizontal plane, let us take a point C here. From this point C to the bottom of the flagstaff, the angle of elevation is given alpha, and to the top of flagstaff, the angle of elevation is given beta. Okay, we have to prove that h tan alpha divided by tan beta minus tan alpha is the height of the tower. Let us take the height of tower as some x. Okay, it is given that AD is equal to h, which is the height of Flagstaff. Okay, height of Flagstaff is given h meters. We need to show that x is equal to h tan alpha divided by tan beta minus tan alpha. Okay, consider first the triangle ACB. Okay, we are considering this triangle ACB. What is tan alpha? We need tan alpha and tan beta, right? Tan alpha. What is tan alpha? Tan alpha is opposite by adjacent. Here opposite is AB and adjacent is BC. AB by BC. Okay. Tan alpha is equal to AB divided by BC. AB is x divided by BC. We can keep it as it is. Okay. Next, consider triangle DCB. When you consider this triangle DCB, here we have angle beta. Okay. What is tan beta? Tan beta will be equal to, again, opposite divided by adjacent. Here the opposite includes h and x. Okay. So h plus x, that is dB divided by BC. dB by BC. dB is equal to h plus x divided by BC. Okay. From this part we can write BC. BC is equal to x divided by tan alpha. Okay. From this, just cross multiplying, we will be getting BC will be equal to x divided by tan alpha. Okay. This I am taking as first equation. Okay. Now from this again we have BC. That BC can be written as BC is equal to h plus x divided by tan beta. Just crossing, BC comes here and tan beta goes here. So h plus x divided by tan beta. I am taking equation 2. Okay. Now comparing 1 and 2. Comparing equation 1 and equation 2. Okay. In both these equations, we have BC on the left hand side. If left hand side is equal, right hand side should also be equal. Yes. So we'll be having x divided by tan alpha equal to h plus x divided by tan beta. X divided by tan alpha is equal to h plus x divided by tan beta. What we need is x is equal to h tan alpha divided by tan beta minus tan alpha. Okay. In both these terms we have x. Now what I am doing is I am crossing. We get x tan beta equal to, this part goes here, h plus x into tan alpha. Okay. Now removing the brackets and multiplying, we get x tan beta equal to h tan alpha plus x tan alpha. Okay. Now bringing the x tan alpha to opposite side, we get x tan beta. Here it is positive side, it becomes negative when taken to the opposite side, minus x tan alpha, and that is equal to h tan alpha. In both these terms, we can find a common x taken out, we get x into tan beta minus tan alpha is equal to h tan alpha. We have almost reached here. This is the required proof. Okay. Then what is there? X will be equal to h tan alpha divided by tan beta minus tan alpha. Just taking this tan beta minus tan alpha to the opposite side. Here it is product. When it taken to the opposite side, it becomes division. So x is equal to h tan alpha divided by tan beta minus tan alpha. So this is a required proof. From both the triangles, we have taken BC and made the comparison and reached the required proof. Okay. Next, problem number 5, question 9 of exercise 22C. The angle of elevation of the top of a tower from 2 points on the ground at distances A and B meters from the base of the tower and in the same straight line with it are complementary. Prove that the height of the tower is root AB meters. Here we have a tower. Let us name it as AB. Okay. B is the base of tower. This is the ground. From the ground, we take 2 points C and D. Okay. One boy is standing here. From here, when he looks to the top of the tower, there is an angle of elevation. We'll take this angle as alpha. Okay. When a boy is at point D, he looks to the top of the tower, there is an angle of elevation and we take this as beta. Given that the angle of elevations from these 2 points, when you take the sum, it should be complementary, which means 90 degrees. Alpha plus beta should be 90 degrees. Also, these points, the distance is given A meters and B meters. Okay, let us take BD as A meters. This distance is point D is at A meters from the base of tower B and point C is at a distance of B meters from the base of tower. Okay. We have to show that the height of the tower is root of AB. Now let us take the height of tower as some h. Okay. We don't know what h is. We have to prove that h is equal to root of AB. Okay. We have the angles complementary. Alpha plus beta is equal to 90 degree. Okay. Now first consider triangle ACB. Okay. When you take triangle ACB, the opposite side to the angle alpha is H and the adjacent side is B. Okay. We need H. H is equal to root AB is what we need. Okay. When you consider this triangle ACB, we will be having tan of alpha equal to AB divided by CB and that is H divided by B. Okay. Next, we have to consider the other triangle which is ADB. Consider triangle ADB. We have tan beta. This angle is beta. Opposite to beta, we have the side AB and adjacent side is DB. AB divided by DB and that is equal to H divided by DB. DB is A. H divided by A. Okay. Here it is given that alpha plus beta is equal to 90 degree. Then we can write beta is equal to 90 degree minus alpha. Yes. So this is tan of 90 degree minus alpha equal to H divided by A. Tan 90 degree minus theta. What is tan 90 degree minus theta? We have studied this. Remember, tan 90 degree minus theta is equal to cot theta. Okay. If tan 90 degree minus theta is cot theta, what is tan 90 degree minus alpha? It will be equal to cot alpha. Cot alpha is equal to H divided by A. Okay. We have tan alpha is equal to H divided by B, which will take as 1, and cot alpha is equal to H divided by A as 2. Okay. Multiplying 1 and 2. We are taking the product of these two equations. We'll be getting left hand side tan alpha into cot alpha is equal to, here we have H by B, RHS H by B into H by A. Okay, we need H is equal to root of AB. What can be done? Tan alpha into cot alpha. that is tan alpha into 1 by tan alpha. Why? Because cot is the reciprocal of tan. Tan alpha will be equal to 1 by cot alpha, or cot alpha is equal to 1 by tan alpha. And that is equal to h square. H into h square divided by b into a, ab. H square divided by ab. This tan alpha and this tan alpha can be cancelled. So, we will be having AB is equal to h square. Taking this AB to the opposite side, we get AB is equal to h square. H square is equal to AB. Now, taking the root on both sides, we get h is equal to root of AB. Okay. What is h? H is the height of tower. Therefore, we have height of tower. Height of tower is equal to root of AB meters. Height of tower is equal to root of AB meters. Understood? Problem 6, question 10 of exercise 22C. From a window A, 10 meter above the ground, the angle of elevation of the top C of a tower is x degree, where tan x degree is equal to 5 by 2, and the angle of depression of the 4D of the tower is y degree, where tan y degree is equal to 1 divided by 4. Calculate the height CD in meters. We have to calculate CD in meters. Okay. Here, the window is 10 meter above the ground. Here, this is the distance, 10 meter. Ground we have BD, and A is the window which is 10 meter above the ground. This is the required horizontal line. Therefore, AB will be equal to ED, and that is 10 meters. Okay. We have to calculate CD. CD is the sum of CE and ED. Yes. CD is equal to CE plus ED. What is given? It is given that tan x degree is equal to 5 by 2 and tan y degree is equal to 1 divided by 4. Okay. We have to find CE. We already know what ED is. We have to find CE. To find CE, CE is a part of triangle CAE. Okay. Taking tan we can find, but we need the value of the adjacent side AE. AE is a part of triangle ADE. Okay. When you consider this angle y degree, this part AE is the adjacent side. So that let us consider triangle ADE. In triangle ADE, tan y degree will be equal to opposite side ED divided by adjacent side AE. We need AE. Therefore, we will have AE is equal to ED divided by tan y degree. Okay. Just crossing, we get AE is equal to ED divided by tan y degree. Put the value ED. ED is equal to 10 meters. 10 divided by tan y degree is 1 divided by 4. 1 by 4. Now taking the reciprocal and multiplying, we get 4 into 10, that is 40 meters. Okay. AE is equal to 40 meters. Now in order to find CE, we have to consider triangle CAE. Consider triangle CAE. Okay. In triangle CAE, we will be having tan x degree is equal to opposite side CE divided by adjacent side AE. Okay. Put the values. We need to find CE. What is CE? CE will be equal to AE into tan x degrees. AE we have determined, which is 40 into tan x degree is given. Tan x degree is equal to 5 by 2. 5 by 2. This becomes 20 into 5. Cancelling. We get 20 here. 20 into 5, and that is 100 meters. Okay. So this part CE is equal to 100 meters. Then what is CD? Just taking the sum, we will get CD. CD will be equal to CE plus ED, and that is 100 meter plus 10 meter, which is equal to 110 meters. 110 meters is your final answer. Okay. CD is equal to 110 meters. Height CD is 110 meters. Okay. Problem number 7, question 15 of exercise 22C. From a point 36 meter above the surface of a lake, the angle of elevation of a bird is observed to be 30 degree and the angle of depression of its image in the water of the lake is observed to be 60 degree. Find the actual height of the bird above the surface of the lake. Okay. Here we have a point A. This is the surface of lake. Okay. From there a bird is viewed, which is at B. Okay. This is the horizontal line. Then the angle of elevation is given, which is equal to 30 degree. Okay, angle of elevation is 30 degree. Then what happens? From the same point A, when the image of the bird is viewed, image of the bird is in the water. When the image is viewed, we get some B dash and the angle of depression will be 60 degrees. Okay, 60 degrees. Let us take the surface, the point on the surface of lake as some C and this point as D, and here let us join this. Okay, and here this horizontal line touching this line, we take it as E. Now just consider this figure. Here it is given that AC is 36 meters. 36 meters above the surface of a lake. Here CD is the surface of lake and A is at 36 meters above the surface of lake. Here these lines are parallel, therefore DE will be equal to 36 meters. Okay, 36 meters. Now let us take this height as some H. What is this height? Here we have the horizontal line. At what angle the elevation is done is 30 degree given. Okay, then the height is taken as H. Clear? From the surface of the lake, the bird is at 36 plus H meters height. Here B dash is the image. Yes, therefore from the surface of lake, B dash should be also at a distance of 36 plus H. This distance will be 36 plus H. Okay, this distance B dash D will be equal to 36 plus H. Here we have BD is equal to 36 plus H. Therefore, B dash D will also be equal to 36 plus H. If B dash D is 36 plus H, what is B dash E? B dash E will be equal to B dash D plus DE. DE is already 36. B dash D is 36 plus H plus 36, which is 72 plus H. B dash E is equal to 72 plus H. Now, why do we need this B dash E? When you consider the triangle AEB dash, B dash E is the opposite side. Okay, so for calculation we require this. Now consider the triangle. Consider triangle ABE. In triangle ABE, we have 30 degrees. Opposite to 30 degree, we have H and adjacent side is AE. Okay. Tan of 30 degree will be equal to BE by AE. Tan 30 degree is 1 by root 3 equal to BE is H divided by AE, or we can write AE is equal to H root 3. AE is equal to H root 3. Okay. Take this as 1. Now consider the second triangle. Consider triangle AEB dash. AEB dash. Okay. Here we have tan of 60 degree is equal to opposite. Opposite is B dash E divided by adjacent. Here again it is AE. Tan 60 degree is equal to root 3. Root 3 is equal to B dash E. B dash E is equal to this one. Okay, B dash E we have determined 72 plus H. 72 plus H divided by AE, which means we can write AE is equal to 72 plus H divided by root 3. This is taken as 2. Next step, comparing 1 and 2. Here left hand side we have AE, right? Left hand side of second equation is also equal to AE. Comparing 1 and 2. We get H root 3 is equal to 72 plus H divided by root 3. Okay. Next step, cross multiplying. H root 3 into root 3 is equal to 72 plus H. Root 3 into root 3 is 3. 3H is equal to 72 plus H. Taking this H to the opposite side. 3H minus H is equal to 72. 3H minus H is equal to 2H. 2H is 72 and H will be equal to 72 by 2. That is 36. Okay, 36 meters. 36 meter is this height. What we have to find? We have to find the actual height of bird from the surface of lake. Actual height of bird from the surface of lake is equal to BD. BD is 36 plus H. H we have determined, that is 36. 36 plus 36 equal to 72 meters. Therefore, actual height of bird from surface of lake is 72 meters. Okay, 72 meters. Clear? Problem number 8, question 18 of exercise 22C. In the given figure, from the top of a building AB is equal to 60 meter high, the angles of depression of the top and bottom of a vertical lamppost CD are observed to be 30 degree and 60 degree respectively. Find the horizontal distance between AB and CD. Second, the height of the lamppost. Horizontal distance between AB and CD, that is the distance BC we have to find. Okay, here we'll be having this line. This is the horizontal line or the line which is parallel to BC. Okay, if two lines are parallel, we know that when a transversal cuts, the angles will be alternate, interior angles will be equal. When you consider this line and BC, we are having 60 degree as this angle. Okay, from this point D, that is the top of the lamp post, we are drawing a line parallel to BC to AB, which is the building. Okay, to AB we are drawing a line which is parallel to BC and I am marking a point E here. Okay, now this horizontal line will be parallel to ED. Why? Because we have drawn ED such that ED is parallel to BC. If ED is parallel to BC and horizontal line parallel to BC, then horizontal line will be parallel to ED as well. We consider this line will be a transversal then. Okay, for this set of parallel lines, we have a transversal. Here the angle is 30 degree. Therefore, this angle will also be equal to 30 degree. So, the first part we have to find the horizontal distance between AB and CD, that is BC. How to find BC? Okay, here it is given that the height of building AB is equal to 60 meter. Building AB is equal to 60 meter high, AB is 60 meter. Okay, we can easily find what BC is. What should be done? Yes, we have to take the tan of 60 degree. We will be having tan 60 degree. Now consider triangle ABC. Okay, in triangle ABC, tan of angle 60 degree will be equal to opposite side divided by adjacent side, that is AB divided by BC. We need to find BC. BC will be equal to AB divided by tan 60 degrees. What is AB? AB is 60. Tan 60 degree is equal to root 3. Okay. Now here root is in the denominator. So we multiply numerator and denominator with root 3. We get BC is equal to 60 root 3 divided by root 3 into root 3 is 3. 60 by 3 is 20 root 3. That is 20 into, what is the value of root 3? 1.732. You will be getting 34.64 meters. Okay, 34.64 meters is BC, this part. Or we can just write it as 20 root 3. The calculation will be easier. 20 root 3 is BC. Next we have to find, so this is the first part. Second part, we have to find the height of the lamp post. Height of lamp post. We have to find CD. Okay, we'll be having CD is equal to, second part, CD is equal to BE. How to find BE? We have AB is equal to 60 meters, and if we are able to find AE, then subtracting AE from AB will give us BE. Okay, AB is equal to AE plus BE. Okay, we need BE. BE will be AB minus AE. Now our aim is to find what AE is. To get AE, consider triangle AED. Consider triangle AED. Here AE is the opposite side of angle 30 degree. Let us take tan 30 degree. Tan 30 degree will be equal to AE divided by adjacent side ED. Okay, what is ED? We have ED is equal to BC. ED will be equal to BC. If ED is equal to BC, we know BC is 20 root 3. ED is equal to BC, and that is 20 root 3. Therefore, tan 30 degree will be equal to AE divided by 20 root 3. We need to find AE. This implies AE is equal to 20 root 3 into tan 30 degrees. Okay, AE is equal to 20 root 3 into tan 30 degree. Tan 30 degree is 1 by root 3. Okay, so here we can cancel root 3 and root 3. So, don't need to put this 34.64 for calculation. Use 20 root 3 so that you can cancel these root 3's. And we get 20 meters. AE. This part is equal to 20 meters. Okay, then what is BE? We have BE is equal to CD. CD is the height of lamp post. CD will be equal to BE, and that is AB minus AE. 60 meters minus 20 meters, which is equal to 40 meters. Okay, this height is 40 meters. Height of the lamp post is equal to 40 meters. Clear? Here we have the final problem for today. Problem 9, question 21 of exercise 22C. The angles of depressions of two ships A and B as observed from the top of a lighthouse 60 meter high are 60 degree and 45 degree respectively. If the two ships are on the opposite sides of the lighthouse, find the distance between the two ships. Give your answer correct to the nearest whole number. Okay, here we have a lighthouse which is at a height of 60 meters. Okay, from this point, from the top of the lighthouse, we can see two ships which are on the opposite sides. Okay, opposite sides. Here, this is a horizontal line, and in the first case, the angle of depression is 60 degree, and to the opposite side, from here, when you look at this ship, the angle of depression is 45 degree. Okay, we have to find the distance between the two ships. Let us take this point as A and this point as B. We have to find the distance between the two ships AB. Okay, now let us mark some points P and Q. P is the top of the lighthouse and the bottom of the lighthouse we are taking as Q. Okay, how to find AB? We know that this line which passes through point P and AB will be parallel. Yes, these two lines will be parallel because this is a horizontal line which is parallel to the ground. If they are parallel, this line is a transversal and this line is also a transversal. When a transversal cuts a parallel set of parallel lines, we know that alternate interior angles will be equal. Therefore, 60 here we have 60 degree and this angle will also be equal to 60 degree. Here we have 45 degree and this angle will also be equal to 45 degrees. Okay, we'll consider both these triangles separately and find what AQ is and BQ is, and then add AQ, BQ to get AB. Okay, we have AB is equal to AQ plus BQ. We have to separately find what AQ is and what BQ is. To find AQ, consider triangle PAQ. Okay, PAQ. Tan 60 degree. Tan 60 degree will be equal to opposite side divided by adjacent side. Here opposite is PQ divided by adjacent is AQ. Okay, PQ is 60 divided by AQ. AQ will be equal to 60 divided by tan 60 degrees. Okay, crossing we get AQ is equal to 60 divided by tan 60 degree. That is 60 divided by, what is the value of tan 60 degree? Tan 60 degree is equal to root 3. Okay, denominator we have root. So what we do is we multiply numerator and denominator with the same number. That is root 3 into root 3. Okay, here root 3 into root 3 becomes 3. That is 60 root 3 divided by 3 and that is equal to 20 root 3 meters. Okay, AQ is 20 root 3 meters. To get the exact value, 20 into, what is the value of root 3? Root 3 is 1.732. 20 into 1.732, you will be getting 34.64 meters. Okay, AQ is equal to 34.64 meters. We'll find BQ. To find BQ, consider triangle PBQ. Okay, to find BQ, consider triangle PBQ. We'll be having tan 45 degrees is equal to opposite side by adjacent side. Here opposite side is PQ. PQ divided by adjacent side BQ. Okay, then what is BQ? BQ will be equal to PQ. PQ is 60 divided by tan 45 degree. What is the value of tan 45 degree? 1. Correct. 60 divided by 1. Therefore, BQ will be equal to 60 meters. BQ is 60 meters and AQ we have determined, that is 34.64 meters. We'll be having AB is equal to AQ plus BQ and that is AQ 34.64 meters plus BQ is 60 meters. 60 meters plus 34.64 meters, we get 94.64 94.64 meters. Okay. So the distance between the ships A and B is equal to 94.64 meters. Clear? Now we have to convert this to the nearest whole numbers. Here we have decimals. Converting to nearest whole numbers. This is 94.64 meters. Converting to nearest whole number, we get 95 meters. So this is the final answer. The distance between the ships A and B is equal to 95 meters. Okay. That's all for today. In today's class, we have discussed problems from exercise 22C. Hope you all enjoyed the session. I'll be back in the next session with a new chapter. Until then, stay tuned to LearnoHub. LearnoHub free hai, par best hai. Thank you.